Lewis used some dot symbols. So Lewis symbols. So dots are being used to represent valence electrons. Okay. So like lithium. So it is having valence electron only one. Yes or no? What is the atomic number of lithium? 3. So its atomic configuration is 1s2, 2s1. Okay. So what Lewis has done, because inner shell electrons are not participating in bond formation. Okay, so inner shell electrons are behaving as if it is stable, completely filled. So they are stable, they are not participating in any type of bond formation. Only outermost shell electrons are participating in bond formation. Okay, so Lewis used dots to represent valence electrons. Okay. Similarly, for beryllium, 4 it is there. Okay, so valence shell, it is consisting of 2 electrons. So some 2 electrons. Right? Okay. Then carbon, what is it? 6. Okay. So carbon 6 is there. So you can say for this one 1s2, 2s1. For beryllium, it is hydrogen, helium, lithium, beryllium. So 4. So 1s2, 2s2. For carbon it is 6. So 1s2, 2s2, 2p2. Yes or no? Okay. So its outermost shell consists of how many? 4 now. Total 4. Second cell, which is valence electron, is 4 only. Though that valence electron we are writing as 2s2, 2p2, but valence electron is 4 only. Okay. So what Lewis has done, see that 4 dot has to be placed separately first. You may think that we will be placing 2 dot here, 2 dot here, then matter is over. No. First single dot should be placed all sides. See, maximum number of elements, maximum number of electrons, suppose there some element M is there, maximum number of electrons it can have in its outermost shell, how many? 8. Either 8 or 2. If it wants to gain helium configuration, then it should have 2. Yes or no? Maximum. If not, if suppose more electrons are there, then 8 only. So maximum number of electrons an element atom will be having 8 in its outermost shell, which can be represented in this form: 2 this side, 2 this side, 2 this side, 2 this side, 2, 2, 4, 6, 8. Correct? It can be represented in this way. So now, when you are representing using Lewis symbols, if suppose 4 is there, first place single dot. Then go for some more electrons are there, then go for 1 by 1 pairing. How? We will see here. So for this 6 was there, nitrogen having 7 electrons. Nitrogen having 7 electrons. Okay. So it means it is having in its innermost shell 2 and then another one 5. Yes or no? So 5 is the valence shell electron in nitrogen. Then 5. So 1, 2, 3, 4. First we will be writing 1, 1, 1. Then one more is left. That one more you can place it with anyone. With anyone. Yes or no? Okay. Now see for oxygen. Oxygen is having 8 electrons. So 8 electrons can be written as 2 and 6. Yes or no? Yes. Valence shell electron is 6. Then 1, 2, 3, 4. Correct? Now 5 and then 6. This dot may come here also, no problem, anywhere. But here 2 pairs only are getting paired. Only 2 sets only are getting paired. 2 bond already it is there for sharing. these will not be participating in sharing in normal cases. Yes or no? First these will be participating. Tell me yes or no? Okay. Now in this case, right, and then fluorine, suppose now fluorine is there, another one we will see. If fluorine, so what is the, you can say, sorry, fluorine means F only. What is the atomic number of fluorine?
9.
Okay, so atomic number of fluorine you can say it is 9. Very good. So 9. So 9 means it is having 2 electrons and 7 electrons. Yes or no? Okay. Once it is 7, then how will be arranging? Again 1, 2, 3 and 4. Yes? Then more 3 are there. Okay. 5, 6, 7. 1 electron is left. Correct? So this will be used as Lewis symbols. Dots. When dots are used to represent valence shell by utilizing this symbol of element, and dots are represented surrounding to it, then it will be called as Lewis symbols. Okay, so Lewis symbols are being used to represent valence shell, and now we will be discussing more for, you can say, how that bond formation will be taking place. Okay, so please note it down. Right. Now let us discuss about that Possel's, what Possel has said. Regarding Possel's findings. Okay? Right. So about Lewis already we saw Lewis dot symbols. Now Possel's findings actually. So Possel's findings was that first group, so first group is most electropositive and seventh group is more electronegative. Correct? Okay. And these two are separated by noble gases. These two are separated by noble gases. Yes or no? How it is separated by noble gases? See, sum of these two will be taking you to noble gas configuration every time. Sum of the first group elements, lithium, sodium, potassium, okay, and this fluorine, chlorine, bromine, now itself we have seen. Okay, so what it is for sodium? It is electronic configuration, and the last is it is having 1 electron for participating, and chlorine was having 7 electrons. So it wants to gain 1 electron, it wants to lose 1 electron. Yes or no? So their difference actually it is noble gas only. Noble gas only. So 8 minus 1, you can say neon minus lithium is giving you chlorine. Means their outermost electronic cell configuration we are talking about. Okay? So neon is giving you 10. Neon is having 10. Correct or not? So neon is having 10 and it is having its 1 electron here in its outermost cell, which is getting subtracted. We are getting 8 electrons, so that 8 electrons wants to achieve that Cl, it will be going for Cl. So you can say both of them are separated by noble gas. Both of them are separated by noble gas, then only sodium and chloride formation has taken place now. Yes or no? Please tell me. See, Na plus has given you 10, means 8. It is also having 8 electrons in its outermost shell. Then chlorine minus also having 8 electron configuration in its outermost shell. It is matching with the configuration of neon. It is matching with the configuration of argon. But 8 both of them have got. So it means most electropositive elements of group 1 and most electronegative element of group 17 both are separated by noble gases. Correct? Okay. So this particular part in sentence we will be writing that most electropositive metals of group 1 and most electronegative elements of group 17 are separated by noble gases. Separated by noble gases. Okay. This electropositive, these are alkali metals. You can write as alkali metals. And electronegative elements of group 17 we can write as halogens. Yes or no? Halogens. Group 17 is halogens. So halogens and alkali metals are separated by noble gas. Tell me yes or no? Understood now? Okay. Right. Second point what he has told. He has told about the formation of negative ion and positive ion. So what it is, halogens will form, or you can say not only halogens, how that positive ion will get formed, how that negative ion will get formed. So the formation of positive ion will take place by giving electrons, by donating electrons, okay, by giving or donating or losing also, by giving, willingly giving, donating also willingly, or losing it somewhere. Somebody has snatched, we have lost. Okay, so by giving or donating or losing electrons, whereas the formation of negative ion will be taking place by accepting okay electrons. Yes or no? Okay. So by giving, donating or losing, or you can say by accepting or gaining electrons, you can write, no problem. By accepting or gaining electrons. Right. Can I rub this? See now bond formation, now this ion formation has taken place, means positive ion formation will be taking place, negative ion formation will be taking place. So what is the achievement? Why this ion formation is taking place? What is the achievement? What they achieved? So they achieved stable octet configuration. Octet configuration they achieved. Yes or no? So that can be written as a point. So the stable octet configuration is achieved by forming positive and negative ions. By forming positive and negative ions. Okay? Right. Also, actually, this octet configuration is applicable for noble gases, all noble gases, except all noble gases, stable octet is there, except helium. Except helium. Helium is having 2 electrons only in its outermost shell. Okay, so that is not octet. Remaining all are having octet, 8 electrons. Okay, so this octet configuration is applicable for all noble gases except helium, for which it is stable duplet, that will be called as duplet. For helium we call it as stable duplet. For all other remaining gases in noble gas configuration, stable octet. Okay, so this is there, stable octet. This is stable octet. Right? Okay. So this was the finding of, you can say, Cosell. So you can define in a general way that the bond formation, or we can define, you can put here as electrovalent bond or ionic bond. So we can say that the bond formation in which positive and negative ions come together by achieving stable octet configuration is called electrovalent or ionic bond. Is called electrovalent or ionic bond. Okay, so due to this formation of octet, it is called as octet rule, Lewis octet rule. Lewis octet rule. So that is Lewis octet rule. So that theory is known as Lewis octet rule theory. Okay. Right. You have written here this side. Very good. Now another bond is there, and that is covalent bond. That is covalent bond. So what we studied in Lewis approach, we saw that bond formation is taking place due to the formation of positive ion and negative ion. And that positive ion and negative ion is coming together and forming a bond by achieving stable octet rule. Okay, so that was called as octet rule. Same octet rule is also applicable here, but in this case, in this covalent bond, forming of ions are not taking place. Formation of ions are not taking place. So particularly we need to note that here in this type of bond, formation of ions are not taking place. The very first point, that formation of bond is not taking, means ions are not forming here. Ions are not forming here. Right. Second, then how that bond formation is taking place? It is just like, you can say, owner and renter relationship. Owner and renter. So mutual sharing, mutual consent. Okay. So the bond formation here, bond formation in covalent bond is taking place due to mutual sharing of a pair of electrons. By mutual sharing of a pair of electrons. Correct? Right. Like, for an example, H2O. For an example, H2O, water. Okay. So water molecule. Now in this we'll see that how it is being shared. So we know that for oxygen we have already designed. So it will be having how many valence electrons? 6. Correct? For oxygen it was Z is equal to 8. Yes or no? 8. So it was having electronic configuration of 2 and 6. So now it means 1, 2, 3, 4. Again 2, 5, then 6. Somewhere here we will put, no problem. Problem is not there. Right. Now another hydrogen. So H2 is there. Now it is having 2 separate electrons where it can form the bond. Correct? So hydrogen will come together and will give 1 electron, and then formation of hydrogen also will be taking place through this one. Yes or no? Right. Here also hydrogen will come here and formation of bond will be taking place with this O. So one is being given by oxygen, 1 electron, another electron is being given by hydrogen. Both of them mutually shared their electrons. It has become a pair electron. So this pair electron has become a bond between them. Correct? This type of bond formation is called as covalent bond. Covalent bond. Right. Similarly, another CCl4. CCl4. So it is what? Carbon tetrachloride. It is carbon tetrachloride. Carbon tetrachloride. In this also, so this carbon, generally the electropositive one, we are keeping it here in center. Right. Okay. So now this carbon C, its electronic configuration was 2 and 4. 2 and 4? Okay. 2 and 4. So it was, you can say C was 6. So 2 and 4. So 4 only valence electrons. So it means it is having 1 here, it is having 1 here, it is having 1, it is having 1 here. Yes or no? Okay. Now Cl, for this Cl, 2, 8, 7, 17. So 7 electrons are there in its outermost shell. Okay, it means it can receive 1 electron. So 1 electron here, it will be given to it, to Cl. So how? So 2, 4, 6. One it was having 7, so along with carbon, it is forming one bond here. Another bond, again Cl will be forming like this, so another bond is getting formed here. Here also that Cl will be forming. Correct or not? Tetra, tetra means 4 Cl is there. So all over, this is also one bond, then here, then Cl. Here also one bond. So carbon is surrounded by, carbon can make maximum 4 bond. So 4 bond formation by Cl. Chlorine, it wants to gain 1 electron. Carbon is ready to give 1 electron. So both of them came near to each other, formed a bond. This is called mutual sharing of electrons. Okay? So this is covalent bond. Right? This one already you have noted down?
Yes, sir.
Okay. So you can say that for this also we will write some 2 points. That what we can say that bond is formed as a result of sharing of electrons. Bond is formed as a result of sharing of electrons. Right? Okay. Sharing of an electron pair. Better we will be writing sharing of an electron pair between the atoms. Another one, so you can say that combining atoms attain the nearest noble gas configuration. Combining atoms attain the nearest noble gas configuration. Right, very good. Please note it down.